What if we told you that a new mineral from the moon might finally give us the solution to the energy crisis that we are facing today? Chinese scientists have discovered a new mineral from several samples that were collected from the lunar surface about 2 years ago as part of the Chang'e 5 mission. Today, private companies like SpaceX and Blue Origin are competing for contracts to get onto the lunar surface and further beyond. It makes sense to get to the moon first, given the fact that the moon is our closest neighbor, therefore making it easy for us to access it, and China is doing just that, as the country is already marking its presence in the space exploration space, especially after the discovery of a new mineral that might change everything about the energy crisis of today. So keep watching till the end to know more. December 2020 was huge for the Chinese National Space Administration because their Chang'e 5 mission landed on the moon and collected about 3.8 pounds of lunar material and then returned the sample to the Earth. This makes it the first retrieval of lunar samples ever since the 1970s, and the agency distributed samples of the samples to nearly 100 groups to uncover the secrets that lie in these samples. That's when a team from the Beijing Research Institute of Uranium Geology managed to isolate a single particle of Chang'e Y, which is just 1/10 as wide as a human hair, because of which the team had to use highly sophisticated processes to isolate this new moon mineral from more than 14,000 other particles in the sample. This is the 6th mineral discovered on the moon by humankind and the first new mineral discovered on the moon by China. This makes China the 3rd country in the world after the United States and Russia to discover a lunar mineral. But is discovering a new mineral important by any means? Well, that might be the case with most minerals, but with the Chang'e Y, things are different. Studying more about the lunar samples will give us more insight to the history of our nearest natural satellite and also what it is made of. But this discovery is even more significant because of the fact that it will have a direct impact on life on our planet instead of the moon itself. So what can we do with moon material? The answer to that is helium-3. This is because Chang'e Y contains helium-3, which is an isotope of helium that's extremely rare on the planet, but this is thought to be available in abundance on the moon. There could be as much as 1.1 million metric tons just in the first several meters of the lunar surface that was explored, which gives us a lot of hope when it comes to solving one major issue on our planet, which is the energy crisis. So what exactly does helium-3 do? Well, to begin with, this is non-radioactive, which means future nuclear fusion reactors could generate energy using helium-3. But that's only going to happen if nuclear fusion becomes viable, and also if scientists are able to generate more energy than what is required to run a nuclear fusion reactor. Fusion reactors have always been touted as the perfect energy source. Proponents of this technology claim that when we have commercial fusion reactors, they would produce vast amounts of energy with very little radioactive waste, forming little to no plutonium byproducts that could be used for nuclear weapons. The pro-fusion advocates also claim that the fusion reactors would be incapable of generating the dangerous runaway chain reactions that lead to meltdown, which means all the drawbacks of the current fission schemes and nuclear power plants will be fixed. Just like a nuclear fission, a nuclear fusion reactor comes with the benefit of producing energy without emitting any carbon that warms up our planet's atmosphere. But there is a problem. It's easier to split an atom to produce energy, like what we have with fission, but it has always been a huge scientific challenge to fuse 2 hydrogen nuclei to create helium isotopes, like what we have with fusion. On the Sun, fusion reactions take place all the time by burning ordinary hydrogen at enormous densities and temperatures. But to replicate that process here on Earth is no easy task, Because we don't have the technology to create intense pressure created by the gravity of the sun's core, because of which we would need a temperature of at least 100 million degrees Celsius, or about 6 times hotter than the sun. So far, with all the experiments done to date, the energy input required to produce the temperature and pressure that enable significant fusion reactions in the hydrogen isotopes has far exceeded the fusion energy generated, which means, with the technology that we have today, is still in its infancy, making nuclear fission simply not viable as an alternative to nuclear fusion. But helium-3 might be the game changer by acting as a catalyst to making nuclear fusion a reality. If we could mine Chang'e Site Y on the moon and then transport it to the Earth, that might solve our energy crisis, because just 40 metric tons of this isotope could power the entire United States for more than a year. So you know that discovery is a true game changer. The lunar samples are extremely important for understanding planetary evolution. The analysis of samples that have been collected by NASA years ago during the era of the Apollo moon landings and then Luna robotic landers of the Soviet Union helped us to learn more about what the moon is made of and how it is formed. These findings, along with the results of recent computer modeling, support the theory that the moon was created out of the debris left from a collision between Earth and a Mars-sized planetary body. During the NASA missions conducted between 1969 and 1972, NASA collected 2,200 samples which weighed about 382 kilograms. These included lunar rocks, pebbles, core samples, sand, and dust from the surface, and today the agency is still studying the samples from the Apollo missions and recently unsealed one of its remaining samples in order to prepare themselves for the Artemis missions to the moon. For those of you who don't know about the Artemis mission, this mission is all about landing the first woman and the first person of color on the moon to explore the southern pole of the lunar surface and also lay the groundwork for sending astronauts to Mars. NASA chose the SpaceX Starship for this mission, the same vehicle that will be used to send humans and cargo to space. What's even more interesting is the fact that China is working on the next phase of exploration by constructing their own lunar base on the moon in the coming decade. The production of the Chang'e 6 probe has almost been completed. To better understand the moon, given that Chang'e 4 went to the far side of the moon for the first time, we, after discussions with engineers and scientists, decided to have the Chang'e 6 probe retrieve samples from the far side of the moon and return them to Earth. So, the samples will be much more valuable. Liu Zhihong, director of Lunar Exploration and Space Program Center, was quoted as saying by CGTN, "The Chang'e 7 spacecraft will be launched to the moon's south pole, followed by Chang'e 6, which will return the samples from the surface." Beijing already completed the feasibility studies of the fourth phase of its lunar exploration program in 2021. China and Russia signed a memorandum of understanding in 2021 to build the research station, which means a lot of things are happening in this space, which is exciting news. The moon's surface is believed to contain as much as 1.1 million metric tons of helium-3 already, and reports suggest that it represents about $1.5 quadrillion worth of resources. So each year, 3 space shuttle missions could bring enough fuel for all human beings across the world for a considerable amount of time. But again, the cost of building and operating a mining operation on the moon is going to be astronomical, because this is not going to be easy and this is not going to be small either. The highest estimated concentration of helium-3 in lunar soil is around 50 parts per billion, and China has not yet released the concentration it discovered in its samples. So, 150 tons of regolith is required to harvest a single gram of this valuable isotope. Things don't end here. You also need to transport this to Earth, and it will involve a lot of overhead costs when it comes to logistics. analyzing the composition of lunar soil and lunar rock samples, and studying nuclear science to assess potential nuclear energy resources on the moon is one of the strategic goals of China's lunar exploration project, reads a China National Nuclear Corporation press release. As we move closer to our goal of making nuclear fusion a reality, now is the right time to ask whether nuclear fusion is really the perfect energy source. Well, with the technology that we have today, it's extremely difficult to scale down the processes that we have on our sun. So, a nuclear fusion reactor would be far away from being perfect, and in some ways, it could also be just the opposite of what we expected it to be. But if all the scientific hurdles that we have with nuclear fusion are addressed and solved, you now have a limitless clean energy source. What an exciting future to be a part of, right?